In this episode, we are going to solve integration problems. We have 4 of them. Let's look at how we will solve this. From the A part, we have integral. So anytime you have your question, you rewrite it tan square x dx. So we want to integrate this. Integration basically means we have to reverse this back to the original differential expression. Are we okay? We have an expression. If we differentiate, we are getting this part. So what is that expression? That is what integration means. Is the opposite to differentiation. So first, if we pay attention, this expression 1 plus tan square x, we can do something about it, right? It's one of the trig identities. We saw that sec square x is equal to tan square x plus 1. This is an identity, right? So meaning the whole of this expression can be replaced by integral of sec square x dx. Are we good? And the integral for sec square x dx is basically tan x. When you differentiate tan x, you are going to get sec square x. So this is the final answer, tan x plus c. So you always have to know your identity such that when you have an expression, you can quickly put that inside. Are we good? Now let's look at the B part. It looks scary, but it is not. So now we have the expression sine theta plus sine theta tan square theta, everything on sec square theta d theta. So once again, we will have to bring in our identities. Are we good? So this expression, I can write it again as, what if I factorize sine theta out? I'm going to get 1 plus tan square theta, everything on sec square theta d theta. So the same thing, as we have this identity, we can see that sec theta plus should be equal to tan square theta plus 1. Are we good? So we can see that this part is what I'm having over here. Are we good? So I can replace this to be equal to integral of sine theta on sec square theta, everything divided by sec square theta d theta. So this can take care of that, and the whole expression we saw is going to be integral of sine theta d theta. Are we good? So now what is the integral of sine theta? And that is going to be equal to negative cos theta plus our constant c. So once you see the problem, don't jump into conclusion and say this is scary. Try to see if you can get any of the trig identities so that you simplify the expression. Let's look at the C part. Now the C, we are having the expression integral of cos 8x dx. So here what we have to do is that first we are going to differentiate what is inside here, and if we differentiate this, that is going to be what? 8, and the integral of cos an angle is going to be sine of the angle, so meaning we are going to get sine 8x. What about the 8 from the differentiation, we are going to divide by 8. So that is going to be 8 plus c. And this is the answer for this integral. The D part, which says we should find the integral of x squared sine s cubed dx. So when we look at this, we can solve this problem by using substitution. So using substitution, I can say let my u be equal to the angle, which is s cubed. So we find du dx, that is going to be 3s squared. Remember, the original question is in terms of x. So if we are introducing u, we can make the expression in terms of what? U. So dx is going to be equal to du on 3x squared. So the final expression is going to be integral of x squared sine u. Now dx is du on 3x squared. Are we good? So this x squared can take care of this, and we are having integral of sine u du on 3. So I can bring the constant out, which is 1 on 3 integral of sine u du. Are we good? So the integral of sine u is going to be, we still have 1 on 3 multiplying integral of sine u, which is negative cos u, plus our constant c. So this can be the same as negative 1/3 of cos u plus c. But then we have u to be equal to s cubed. And our expression is going to be negative 1/3 cos s cubed plus c. So this is our final expression. Are we okay? Alright, so this is by substitution approach, and we are getting a final answer. You can pause the video and try your hands on some of the questions. Please subscribe to the channel and see you in the next episode.